In this video, we're going to take a look at exam revision for statistical distributions. So what we're going to do here is take a look at 4 exam style questions, 2 on probability distributions, otherwise known as discrete random variables, and 2 questions on the binomial distribution. And like always, pause the video, have a look at the questions as they appear, and then double check that your solution matches what we get on the screen. Other than that though, I think that's everything that we need here to get started. So let's begin now with question 1. Starting off with question 1 now, where we have the random variable x, which has the following probability function. So the probability that our random variable x is equal to some value x, that is equal to x over 15, where x can take these following values here. So for the first part then, part A, pretty standard, we just want to construct a table for the probability distribution of our random variable x. So for part A then, well, the first thing that we need to do is actually construct the table. So to make this a little bit neater, I've got my table here. Now, remember, for the top row here, this is the values that our probability function can take. So this would be x, so little x here. And x can take these following values here. So 1, 2, 3, 4, and 5. We've got 1, 2, 3, 4, and 5 there. And then here, this row underneath, this is the respective probabilities. So this is the probability that our random variable x is equal to some value, which is x. Okay. So here, what we need to do now is find these probabilities here. So how do we do that? Well, all I do then is I substitute these values of x here into our probability function. When x is 1, we get 1 over 15. We've got 1 over 15 there. And obviously keep these in their exact form like this here as a fraction. Don't change these to decimals. So we get 1 over 15. Then when x is 2, we get 2 over 15. So 2 over 15. When x is 3, we'd get 3 over 15 or 1 over 5, whichever you prefer to put that as. I'll put it as 1 over 5. When x is 4, we get 4 over 15. And then finally, when x is 5, that would be 5 over 15, which is 1 over 3. We get 1 over 3 there. And there we have it. So that's the table there for the probability distribution of x. So that's part A done. Now for part B then, we're now looking to find this probability here for our random variable x. So we're looking for the probability that x is strictly less than 4. The probability that x is strictly less than 4. So how do we find this probability here? Well, we need to actually look at what values we want here for our random variable x. So we want values of x strictly less than 4. So clearly we can't take 4 or 5 here because they're not strictly less than 4. So what that means then is x going to be equal to 1, 2, and 3. These are the values that we can take. So what I need to do now is add those respective probabilities up. So it's going to be 1 over 15 plus 2 over 15 plus 1 over 5. I've got 1 over 15 plus 2 over 15 plus 1 over 5. So add these together. So 1 over 15 plus 2 over 15, that's 3 over 15. That would be 1 over 5 plus 1 over 5. So that gives me 2 over 5 there, or 0.4. That's 2 over 5 or 0.4, whichever you prefer there. Okay. And there we have it. So that's the solution to part B. Hopefully nice and straightforward. And then for part C, we just want to find another probability here. So we're looking for the probability that x is between 3 and 5, including both 3 and 5. So let's just write down that probability again here. So x is between 3 and 5, including both of those values. So again, we just refer to the table here for our probability distribution. So what values are we actually looking for here? Well, we're looking for 3, 4, and 5 because we include both 3 and 5. So we can take 3 here, 4, and 5. So again, all we need to do is sum those respective probabilities. So it's going to be 1 over 5 plus 4 over 15 plus 1 over 3. So all you need to do here is just evaluate this summation here. So just put it into your calculator if you want. And if you do this correctly, what you should find then is you get 0.8. We get 0.8 there, and there we have it. So that's the solution to C, and that gives us the solution there to question 1. Moving on to question 2 now, where we have a question here on the binomial distribution. We've got the random variable x, which follows a binomial distribution where n equals 16 and p equals 0.45. So here, all I want to do is find these 3 probabilities. Let's start with part A then. So here we're looking for the probability that our random variable x is equal to 9. So the probability that x, our random variable x, is equal to 9. So here to find this probability, I'm going to simply use my calculator. Or you can just use the formula, but I just prefer to use the calculator. I find it a little bit easier. So I go into stats mode. Then I press distribution. So it's distribution. Then it's binomial. Binomial. And then, because it's an exact probability here, so it's probably that our random variable x is equal to some value, then it's going to be BPD. Okay, it's not a cumulative probability, it's exact, so it's BPD. I've run out of room a little bit here, so BPD. Okay. So here it asks us for a few different things. So it asks whether the data is a variable or a list, but obviously it's going to be a variable. Then it asks for the value of x, that would be this value here. So x equals 9. The number of trials, so that's n, well, that would be 16. And then p, our probability of success here, that's 0.45. So input those values and then press enter. And then what this gives us here is our respective probability. So now if I round this here to say 3 significant figures, I get 0.132. So 0.132 there. And there we have it. So that's the solution to part A. Now for part B, we're looking for the probability that x is greater than or equal to 9. So the probability that x is greater than or equal to 9. Well, because this involves greater than or equal to, this is going to be a 1 minus probability. It's going to be 1 minus the probability here. And then we have our random variable x. So now we need to decide what values we're going to subtract off here. So let's just consider what values we actually want. We want x being greater than or equal to 9. So that would mean I want 9, 10, 11, 12, and so on. That would keep going. So basically, we just want values that are 9 or greater. So we want to subtract 8 and lower. Okay, so 8 and smaller, I should say. So x is less than or equal to 8. So what we're going to do here then is just put this probability now into our calculator, or evaluate this probability here using binomial cumulative. So that's BCD. So again, it's distribution. Then it's binomial. And then finally, it's BCD now, because we have a cumulative probability. So BCD then. So now the only thing that will change here is the value of x. Obviously, the number of trials n and p won't change. We have the same random variable x. But x now is actually 8. So change that to 8 and then press enter. And what I get here then is 0.74410851. So let's do 1 minus here. 0.744. Let's do it to say 5 decimal places. So that would be 1, 1. And now if we subtract this here, so 1 minus 0.74411. So 1 minus 0.74411. That gives me 3 significant figures again, 0.256. So we get 0.256 there. And there we have it. So that's the solution to part B. And then we have part C here. So this is a little bit challenging now. So we're looking to find the probability that x is between 6 and 10, including 6, but excluding 10. So let's just write down that probability here. So x is between 6, including the 6, and between 10, but excluding the 10. So we need to think about this in 2 parts here. So we've got like the upper bound essentially of this probability, and then we've got this lower bound here. So we need to be below 10, but not including the 10. So in other words, we want 9, 8, 7, and so on. And we also want 6 here as well. Okay, so we want to include that 6, but no lower. Okay, so here what I'm going to do then is find the probability that x is less than or equal to 9, because we don't want the 10. So x is less than or equal to 9. And what I'm going to do now is I'm going to subtract here anything below this here as well. So we don't want, say, 5, 4, 3, 2, or 1, or 0, for example. So now what we need to do is subtract the probability our random variable x is less than or equal to here. Like we said, we don't want 5, 4, 3, and so on. So it's going to be x less than or equal to 5. Okay. And what that would leave me then with is the probability that x is between 6, 7, 8, and 9. Okay. So let's evaluate now these two cumulative probabilities here. So again, it's distribution, binomial, BCD. So two cumulative probabilities here. So for this one, we just change x to be 9. Obviously, n and p don't change. So this here would give me 0.87589 6. So 0.87589,699. So that's the total probability there. Okay, I'll keep all figures here on my calculator. Obviously, later on we'll round it down anyway, or at the very end we'll round it down to a sensible degree of accuracy. Doing the same now here for the probability that x is less than or equal to 5. So I'll just change x here to be 5. So here I'm going to get minus 0.197 597 56. So now if we evaluate this difference here, just put this into your calculator. It's 0.87589,699 minus 0.197 59756. And then here, if we round this to, again, 3 significant figures, I get 0. So I've got 6, 7, 8 there. Okay, and that's 2, 3 significant figures. So obviously, I didn't quite need as many decimal places here as I've rounded it to, or what I've took from my calculator, but I just want to make sure it's definitely accurate here. So that's fine there. Evaluate the difference then using your calculator, and you should get this value here. So 0.678. And there we have it. So that's the solution to C. And that gives us the solution there to question 2. Moving on to question 3 now, where we have the discrete random variable x, which has the probability distribution shown in the table below. So we can see our table here. And for the first part, then we just want to find the value of k. So for part A, we want to find the value of k. So what we can see then is for two values of x, namely 1 and 3, those respective probabilities involve k. So how do we find the value of k? Well, we simply use one of the properties here for discrete random variables. So we know that the sum of these probabilities here will be equal to 1. In that case, then the summation here of these probabilities that will be equal to 1. So here I take each individual probability, add all those together, and set that equal to 1. Then what we can do is go on to solve for k. I've got 2k plus 0.1. We've then got 0.18, so plus 0.18. We've then got 0.4 minus k. And then finally plus 0.12. And we know this here will be equal to 1, because this here, the left-hand side, is simply the summation of the probabilities. So now we simplify the left-hand side here. Well, I've got 2k minus k, so it would just give me k. And then I've got 0.1 plus 0.18 plus 0.4 plus 0.12. So that will simplify to give me 0.8. So we get k plus 0.8 there. And that is equal to 1. Then finally, we solve for k here. We get k equals 0.2. And there we have it. So that's the solution to part A. So now for part B, it asks us to find this probability here. So we're looking for the probability that our discrete random variable x is strictly greater than 3. Now, we don't need it for part B anyway, but let's just replace these probabilities here with their actual numerical value. So k is 0.2, so that's two lots of 0.2, so that's 0.4 plus 0.1, so that's 0.5. And then for this probability here, it's 0.4 minus k, so that's 0.4 minus 0.2, that's going to be 0.2 there. So for part B then, we're looking for this probability here. So the probability then that x is greater than 3. So what values of x do we actually want here? So if x is greater than 3, there's actually only one value we can take here, and that would be when x is equal to 4. So it's this column here. So in that case then, that probability is simply going to be 0.12. So that's 0.12, hopefully nice and straightforward. And then finally for part C here, we've got this probability here, so the probability that x is between 2 and 4, including both 2 and 4. So let's just start by writing down the probability. So x is between 2 and 4. So what values of x do we actually want here? Well, I would want 2, because we're including the 2. We'd want 3, because that's between 2 and 4. And then we also want 4. So those probabilities that we want here would be 0.18, 0.2, and 0.12. So what we're going to do then is add those together. So I've got 0.18 plus 0.2 plus 0.12. So add all these together here. And what you should find then is you get 0.5. Okay. And there we have it. So that's the solution to C, and that gives us the solution there to question 3. And finally, if we take a look now at the very last question here, question 4, we have the probability that a light bulb has a defect, and that's given as 0.05. We're told that a random sample of 12 light bulbs are taken from the production line. So for the first part here, part A, we want to define a suitable distribution to model the number of defective light bulbs in this sample. So for part A then, we just need to start by defining the distribution here that we're going to use. So sometimes it won't ask you to do this, but it's always a good starting point anyway. So here, I'm going to let x equal the number of defective light bulbs. So let x equal the number of defective light bulbs. Just start by jotting that down. So now we can model this here as a binomial distribution. So x will follow a binomial distribution. And for our parameters here, we're going to have n and p. So n is the sample size of the number of trials. In this case, that would be 12. So n equals 12. And p here, that's the probability of success. So that would be 0.05 in this context. So 0.05 there for p. And there we have it. So that's all we need there for part A. So like you can see, not much work there involved for actually defining the distribution. We just need to mention what the random variable represents. So in this case, the number of defective light bulbs, and then give the distribution. So that's part A done. So let's take a look now at part B. So for part B, it says find the probability that the sample contains 2 defective light bulbs. So what we're looking at here is a question in context. What we need to do is take this line here, this context question, and translate that into a basic probability. So here, if we're looking for the probability that the sample contains 2 defective light bulbs, what we're saying then is x equals 2, exactly 2. Okay, so here, we're looking for the probability that x, our random variable x, is equal to 2. So in this case here, we can either use the formula, or we can simply use our calculator here, and I'm going to simply use my calculator to find this probability. So I'll start by going into stats mode, then we have distribution, then it's binomial, and then finally here, because it's an exact probability, it's going to be, so it's distribution binomial, it would be BPD because it's exact. So BPD there. So here it asks us for a few different things. So x, that would be this value here. So x equals 2. The number of trials, in other words, what is n? Well, that would be 12. So n equals 12. And then for the probability of success here, that would be 0.05. So change p to be 0.05. Input those and then press enter. And what this gives me here then is this probability then. So this is the probability that our random variable x is equal to 2. So here, if I give my answer to, say, 3 significant figures, I get 0.0. Let's just write this down. So 0.0988. Okay. And there we have it. So that's the probability that x equals 2. In other words, the probability that the sample contains 2 defective light bulbs. And then for the final part here, part C, we're looking for the probability that the sample has at least 1 defective light bulb. So here we see this phrase straight away, at least. So we know that this is going to be a greater than or equal to problem. So because we're looking for the sample having at least 1 defective light bulb, it's going to be the probability then that x is greater than or equal to 1. Okay. And because this is a greater than or equal to problem, we're now going to subtract some values that we don't want. Okay, so it's going to be 1 minus the probability here. So if we just think about this for a moment, what values of x do we actually want? Well, I want 1 and greater, so 1, 2, 3, 4, and so on. That keeps going. So what values of x do we not want here? So the ones that we don't want, that's what we're going to subtract off. So the only value that we can't actually have here would be x equals 0. This is going to be 1 minus the probability that x equals 0. So here then, we now need to find this probability here on our calculator. So probability that x equals 0, it's an exact probability, so it's going to be BPD again. So distribution, binomial, BPD. So the only thing that will change here is the value of x. In this case, x equals 0. So change x to 0, input those values, and then press enter. And what I get here then is 1 minus. So this value here then is what I've just found on my calculator. So I get 0.540. So 54036. Let's just round it to 5 decimal places like that. And now let's find the difference here. So 1 minus 0.54036. And then if I round this to 3 significant figures here, I get 0.460. So 0.460 there. Okay. And there we have it. So that gives us the solution to C, and that gives us the solution there to the very last question, question 4. And that actually brings us to the end of this video on exam revision for statistical distributions.